So, hello students, this is a video for the topic test that we have designed to help you prepare better. These tests are designed so that you take these tests once you've covered the basic concepts of a topic. These are topic tests, five tests for each topic, uh, for not just topic but subtopics also for all the topics of QA. So once you have completed the concepts of a topic, say time, speed, distance, you've covered completely, you've practiced questions. That is where you take these tests. So these tests will be a mixture of all the subtopics. Each test will be a mixture of various subtopics, and there'll be 10 questions. Once you have attempted the test in a timed manner, you look at the video to get a perspective of what could have been a good attempt, which questions should have been chosen, why they could have been chosen, what would be a good time or an ideal time to attempt these questions. If you do like the test and the videos, there are almost 200 topic tests that are available on the Bodhee Prep Android app. The link for the app is in the description of the video. Download the app and make use of these tests that we have prepared for you. This video is about the time, speed, distance topic, test number 4. Overall, the test was a moderate test. Attempt time was about 18 to 21 minutes. Not the questions that were to be done were not very calculation heavy. And I think six questions net correct would be a good attempt in this test. A man is 20 minutes late to his office if he drives at an average speed of 40 kilometers per hour and is 4 minutes early if he drives at 50. By how much time will he be early late if he drives at 48? Now, in the first case, speed is 40 kilometers per hour. Suppose the original time that should be taken is t minutes to travel. At 40 kilometers per hour, he's taking 20 minutes more. Therefore, t plus 20 minutes is being required. At 50 kilometers per hour, he's 4 minutes early. So he's requiring t minus 20 minutes. T minus 4 minutes. 4 minutes early, not 20. But the distance covered in both cases is same. So what we can do is we can say the distance is same. The ratio of speed is inverse to the ratio of time. S1 T1 is equal to S2 T2. This is condition 1, this is condition 2. Again, note here that we do not have to write t plus 20 by 60 because we are taking the ratio of time. Whether it is minutes, whether it is hours, it will cancel out. All I'm saying is I have taken this t in minutes, so I can add t and 20. So values will be 40, 50. T2 will be t minus 4, T1 will be t plus 20. Cross multiplying 4t plus 80 is equal to 5t minus 20. 5t minus 40 is t, 80 plus 20 is 100. So time taken ideally should be 100 minutes. Now, if we look at this case and then compare it with the new speed, which is 48 kilometers per hour, and find out the time required here. So 50 into t minus 4, which is 100 minus 4, will be 48 into the time required. Let the time required here be x in minutes. So 48x, this gives us 50 into 96 is equal to 48x, which gives us the value of x as 100. So at the speed of 48, time required will be 100 minutes. And that is the time that is normally required, or should be ideally required. So if he drives at the speed of 48, how much time will be early or late? None of the above. He will arrive exactly on time. Level of difficulty, let's say a moderate level of difficulty, solving time about 2 minutes. In a race of 3 horses, the first beat the second by 11 meters and the third by 90. Horse 1 beat the second horse by 11 meters, the third horse by 90 meters. If the second horse beat the third horse, second horse beat the third horse by 80 meters, what is the length of the race course? Now, when the first horse just reaches the finish line, H2 is 11 meters behind. So from this point to finish the race, H2 has to run 11 meters or cover 11 meters. Also from this point, H3 is 90 meters behind the finishing line. By the time H2 reaches, H3 is 80 meters behind the line. So in this same time, when H2 has run 11 meters, H3 would run 90 minus 80, which is 10 meters. And therefore, ratio of speeds of H2 or H3 can be given as 11 is to 10. So basically, whenever H2 runs 11, H3 will run 10 meters. Now, when H2 finishes the race, H3 is 80 meters behind H2. Here, the difference is 1. If we want to make the difference as 80, let us multiply everything by 80. So multiply 80 to this ratio, 880 is to 800. So when H2 runs 880, H3 will run 800. Since H3 is 80 meters behind, that means it is this scenario only. So H2 has just finished the race by running 880 meters. So the length of the race in meters is 880. That becomes the answer. Overall, I'd say easy to moderate question, not more than 90 seconds to solve. Would have done such questions earlier as well. Could use proportionality as well, where we say if the race is x meters, in the first case, H2 has run x minus 11, H3 has run x minus 90, ratio speed of H2 and H3. This will remain same in the second case where H2 has run x the entire race, H3 has run x minus 80. Putting the values, we will still get the value of x as 880. If train A crosses train B, the length of which is thrice of A. So if the length of A is x, the length of B is 3x length. In 90 seconds when the two trains are traveling in opposite direction with equal speeds. Okay, so opposite direction, this is train A, this is train B. Length of train B is 3x. Opposite direction, let the speed be s for both of them in 90 seconds. So if the speed is in meters per second and the length is in meters, we can say when two trains cross each other, the total distance traveled will be the length of the two trains. Since then the opposite direction, the relative speed will get added. So 3x plus x total distance upon total relative speed is equal to time, which means 4x by 2s is equal to 90. They cross each other in 90 seconds. Find the time taken by the train to cross a stationary pole. For A to cross a stationary pole, the distance will be equal to the length of the train, and the speed of the train will be speed of A. So time taken will be length of the train here is x, speed of A is s. So basically time taken will be x by s. From here we get 2 2s are 4. So 2x upon s is 90 divided by 2, x by s will come out to 45. So to cross the pole in seconds, A with the same speed will take 45 seconds. And that becomes the answer. Overall, I think trains based, easy to moderate question. Should not take more than a minute, minute and a half to solve. A bus covers a journey at an average speed of 90 kilometers per hour if the time for which the bus stops during the journey is excluded. Then the average speed of the journey becomes 108 kilometers per hour. For how much time on an hour? On an average, does the bus stop every hour? Basically, the bus is able to cover 90 kilometers in 1 hour, but that is because it is stopping. Whenever it travels at 108 kmph. Now, at this speed, to cover 90 kilometers, what will be the time? Time will be distance upon speed. This is in hours multiplied by 60 to get the time in minutes. So to cover 90 kilometers at the speed of 108, time taken will be 90 upon 108 divided by 18. 5 by 6 into 60 or 50 minutes. But 90 kilometers will be covered in 1 hour. That means for the remaining 10 minutes, 60 minus 50, the bus is not moving and therefore not covering any further distance. So on an average, the bus stops for 10 minutes every hour. We could also allegate the moving speed is 108, the stationary speed is 0, and therefore the overall speed comes out to 90. Difference of 18, difference of 95 is to 1. This will be the ratio of time at the two speeds. 1 hour is 60 minutes. Divide 60 in the ratio 5 is to 1. 50 minutes moving at 108, 10 minutes moving at 0 or stationary. That becomes the answer. Either ways, similar questions have been asked in the CAT exam as well. Easy question, therefore, and solving time should not be more than maybe a minute or at most a minute and a half. There are 13 equidistant bus stops on a straight road. A bus running at 60 kilometers per hour is some distance away from the first stop, from where it will move towards the 13th stop. Two cars start running from the 6th stop. Suppose stop 1, stop 1, stop 2, and so on. Here is stop 6, stop 7. This is say stop 13. S1, S2, S3 is what I marked as for the stops, equidistant stops. Also, suppose here is the bus running towards the stops. Cars start from the 6th stop. Two cars start running from 6th stop in opposite direction. One car goes here, the other goes here. With the same speed, if the bus meets one of the cars at the first stop, so the bus and the first car meet at the first stop, and the other at the 13th stop, and the bus and the second car meet at the 13th stop. So this is the first situation. This is the second situation. Too many lines. We have to find the speed of the cars. The speed of the bus is 60. Okay. Now, in the time that the bus reaches S1, one of the cars has reached from S6 to S1. So it has covered a distance of 5 stops. In the same time, when the bus reaches from this point to S1, the other car will cover the same distance in the opposite direction. So it will reach at S11. 6 minus 1 is 5. One car does 5 in one direction, the other will do 5 in the other direction at the same time. Now, if we look at this scenario, the bus at this point is at S1. It has to go to S13, so it has to cover 12 stops. The second car is at S11. It has to go to S13 in the same time. So it has to cover 2 stops from 11 to 13. This is the bus, this is the car. And therefore, we can say the time that the bus will do 12 stops, the car will do 2 stops. So the ratio of speed of bus is to car has to be 12 is to 2 or 6 is to 1. Since the speed of the bus is 60, the speed of the car will be 10. 10 kilometers per hour becomes the answer. This question, I think, is a moderate to difficult level of question if you've not done it earlier. Also, if you try to do it using equations, it becomes a legitimately decent question. But comparing the two cases makes it a lot easier to solve. Solving time, if you're making equations, could go up to 3 odd minutes. Otherwise, 2 to 2.5 minutes should be good enough. Anu and Prem started running simultaneously from diametrically opposite points on circular track. Anu and Prem started running on opposite point. They ran opposite directions. If Anu runs here, Prem runs here, and they met after 12 minutes. So together they are covering half the circle, half circle together in 12 minutes. If the distance between them exactly t minutes after the start is equal to quarter of the length of the track, which of the following is not a possible value of t? In this case, the first time that the distance will be quarter of the track when they have covered quarter of the track together. So that will take 6 minutes. This will be a position where suppose A has reached somewhere here, P has reached somewhere here, and the difference between them is a quarter of the track. This will happen half the time. Eventually, they meet after 12 minutes to create a further distance. Of, suppose they meet here at some point, to create a distance of a quarter of the track, they will require another 6 minutes. So the next time this happens will be at 6 minutes after 12, which is 18 minutes. The second meeting is supposed to, since the first meeting happened in 6 minutes for half the track, the next meeting will happen, or the similar situation will occur after the first meeting happened after 12 minutes, half the track. So the next meeting will happen after 24 such minutes, 24 minutes after the first meeting, that is after 36 minutes. 6 minutes before this also the difference will be quarter of the track, because together they are doing 1/4 of the circle in 6 minutes, half the circle in 12 minutes, and therefore full circle in 24 minutes. So both of these conditions will start repeating after every 24 minutes. So if this happens at 6 minutes, it will happen at 6 plus 24, 30 minutes. It will happen at 30 plus 24, which is 54 minutes. 54 plus 24, 78 minutes. 78 plus 24, 98. 102, adding 24, 126, 150, and so on. Similarly, this condition will be repeated after every 24 minutes, because in 24 minutes they complete a circle together and therefore they're in the same position. So 42, 66, 90, 114, 114, 1 adding 24, 138, 150, 162, and so on. As we can see, 78 is there, 90 is there, 42 is there, 144 is a multiple of 12. Since they meet after 12 minutes, the next meeting will happen after 24 minutes. Therefore, we can say the meetings will happen at 12, 36, and so on. These will be multiples of 12. Since 144 is a multiple of 12, they would be probably meeting at that point, will not be the distance of a quarter of a circle at that point, and therefore 144 cannot be a value of t. I think moderate level of difficulty question, solving time of 2.5 minutes if you are comfortable with the concept of circular motion. Rajesh and Ramesh are running on two different circular tracks. Both of them took the same time to complete one round each of their respective tracks. Suppose track 1 has length of L and Rajesh has speed of L. This is meters per second. So time taken will be 1 second to complete one circle. For Ramesh, let the length of track 2 be x meters and his speed be x meters per second. So again, 1 second to complete one circle. They interchanged the tracks and Rajesh completed 2 rounds in the time in which Ramesh completed 1 round. So here Ramesh will complete 1 round in L upon x, distance upon speed. In this time, Rajesh is doing 2 rounds. 2 rounds means a distance of 2x is covered at a speed of L. Find the ratio speeds of Rajesh and Ramesh. You have to find the value of L upon x. So cross multiplying L square upon x square is equal to 2 by 1. Taking root L upon x is equal to root 2 upon 1. That becomes the answer. Basically, assuming the length and speed same for Rajesh, L and L, for Ramesh, x and x. Now Ramesh, when he does the first circle, will take L by x seconds. Rajesh will do 2 rounds and therefore will cover 2x distance at a speed of L in the same time. The time is equal. From here, we'll get the ratio of L and x as root 2 is to 1. Option A. I think if you're able to visualize this, it's an easy question. Solving time would be about 1.5 minutes. 3 boys A, B, and C start running at constant speeds from the same point B along the circumference on a circular track. The speeds of A, B, C are 5 is to 1 is to 1. A, B, C speeds are 5, 1, 1. A and B run clockwise, same direction. C runs anti-clockwise. Each time A meets B or C on the track, he gives them a card. What is the difference in the number of cards received by B and C if A distributes 33 cards in all? Since A and B are moving in the same direction with speeds ratio 5 is to 1, when A does 5 rounds, B would do one round, ratio speed 1:1, 5:1, and C would do one round. Since A and B are in the same direction, number of meetings of AB will be 5 minus 1, that is 4. Number of meetings of AC will be opposite direction, 5 plus 1, which is 6. So when B gets 4 cards, C will get 6 cards. Then this process will repeat. So total 10 cards is given. The multiple of 10 less than 3 is 30. Multiply by 3. So when B has gotten 12 cards, by the time C would have gotten 18 cards. All of them will be at the starting point between A, B, C. The next meeting will happen between A and C, somewhere here. So C now has 19 cards, B still has 12. A will move on, B and C will meet. Now, if we look at the meeting that is happening between A and C, A and C will meet somewhere here. C, A. A will go on. Since there are 6 meetings happening, we can divide the thing into 6 points. 1, 2, 3, 4, 5, 6. 6 equal points. This is the meeting point of AC. And for AB, there are 4 meeting points. So they can be marked as 1, 1, 2, 3, 4. The first meeting with C will happen at 1, 2, 3, 4, 5 at this point. So here A and C will meet. The 31st meeting will happen overall, including AB meetings, and the 31st card will be given. After that, the meeting between A and B has to happen 1, 2, 3, 4, 5, which will happen here. One, two, three, four, 5. So A and B will meet here. The 32nd card will be given. The first meeting of AC. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The second meeting of AC. Yeah, okay. So if we mark the meeting points or the order of points of A and B meeting, A and C meeting, the red one are AC meeting points, dividing the circle into 6 equal parts. The blue ones are AB meeting points, dividing the circle into 4 equal parts. Now, if we mark the meeting point, here the first meeting of AC happens, counting because the speed of C is 1, so 1. This is where the second meeting will happen. This is where the third meeting will happen. This is where the fourth meeting will happen. This is where the fifth meeting will happen. Eventually, sixth here. If we look at B, B is going in the same direction. So the first meeting happens here. The second meeting for AB happens here. The third happens here, and the fourth at the starting point. Now, when ABC, all of them are at the starting point, the first point that will happen for A and C both will be this point. The 31st card will be handed over here. The second meeting or the next meeting will happen between A and B at this point, where the 32nd card will be handed over. And then the next meeting will happen for A and C at this point, where the 33rd card will be handed over. So after the 30th cards, one card to C, one card to B, and then finally one card to C. So out of 33, C will get 20 cards, B will get 13 cards, which is a difference of 7. Hence, the answer to this question would be 7. I'd say this is a moderate to difficult level of question. The first 30 cards is not very difficult. Then finding the 3 points is essentially the challenge, and therefore say moderate to difficult level. But the solving time, depending on how well we are able to see the last 3 points, will be 2 to 2.5 minutes. Anshul and Nitish run between points A and B, which are 6 kilometers apart. Anshul starts at 10. From A reaches B, Anshul. Starts from A, reaches B, returns to A. Nitish, this he does at 10 a.m. Nitish starts from B, reaches A, comes back to B. This he does at 10:30 a.m. Their speeds are quantum. Nitish being twice that of Anshul. So if Anshul's speed is x, Nitish's speed is 2x kilometers per hour. While returning to the starting point, we meet at a point which is midway of A and B. So Anshul goes to B, comes back, and is here. Meantime, Nitish goes to A, comes back and meets. Now both of them have covered a distance of 6 and 3, 9 kilometers. But the ratio of speed is 2:1. So we can say that the ratio of time traveled by Anshul is to time traveled by Nitish. Has to be for the same distance. Both of them have covered. Anshul goes from A to B 6 kilometers and half of AB, which is 3. Nitish goes from B to A 6 kilometers and half of AB, which is 3. So for the same distance, if speed ratio is 1:2, time ratio has to be 2:1. Inverse of the speed. Now we know that if Anshul has taken X hours, uh, Nitish would have taken half an hour less than that because he started half an hour late. So we can say X is equal to half of, or rather, time taken by Anshul X is twice of time taken by Nitish, which is X minus half because he started half hour late. X is equal to 2x minus 1. X is equal to 1. That means this meeting is happening 1 hour after Anshul started, that is 11 a.m. The meeting is happening at 11 a.m. Now, if we go back to the uh, starting point, and we know that Anshul will reach the midpoint at 11 a.m., what he has done is covered 3, 3, and 3, 9 kilometers in 1 hour, 60 minutes. So he will cover 3 kilometers in one third of this, that is 20 minutes, and therefore he will cover 6 kilometers in twice of 20, which is 40 minutes. That means Anshul starts at 10, is here at 10:40. This is the time when he will start going back. Where is Nitin at that point in time? If we look at Nitish, not Nitin, Nitish covers 9 kilometers in 30 minutes. Therefore, he will cover 6 kilometers, or rather 3 kilometers, in one third of this, that is 10 minutes. And therefore, 6 kilometers, the distance, in 20 minutes. So they will end up crossing each other because 10:30, 10:50. So first meeting would have happened by now. Let us go take ourselves one step behind. Let us see where Anshul is when Nitish starts to run. Nitish will start to run at 10:30. What is the distance that Anshul will cover in 30 minutes? Because he does 9 kilometers in 60 minutes, he would cover 4.5 kilometers in 30 minutes. And therefore, at 10:30, Anshul would have covered a distance of 4.5 kilometers, would be going towards B, and this is where Nitish will start running. The distance between them is 1.5 kilometers. 1.5 kilometers is the distance between them. Time taken to cover this distance will be 1.5 kilometers is the distance, or if you look at the speeds here, speed of Anshul is 9 kilometers in 60 minutes, so 9 kilometers per hour. Speed of Nitin therefore will be double of that, it is 18 kilometers per hour. So to cover a distance of 1.5 kilometers, the relative speed will be 1.5 on 27 hours, so multiply by 60, which becomes 15 into 6 by 27 divided by 359 divided by 3 2 3. So 10 by 3 minutes will be required. 10 by 3 is nothing but 3 1 by 3 minutes. So after 10:30 when Nitish starts, another 3 1 by 3 minutes is required. So the first meeting will happen at 10:33 1 by 3 a.m. Again, level of difficulty was actually moderate to difficult. I kind of got lost towards the end where the timing was to be found out. But again, the challenge here is you'll have to first find out the time that they are taking to complete the rounds, and then from there we get an idea of speed and how relatively the speed will get or the distance will get covered. Easily 2.5 to 3 minutes to solve the question. Car A left city C1 for city C2 at 6 a.m. At 9:30 a.m., car B left city C1 for city C2 at the speed of, and the speed was 12 kilometers per hour more than the speed of A. At 4:30 on the same day, two cars are 91 kilometers apart. So both are leaving C1. One leaves at 6 a.m., which is car A, C1. The other leaves at 9:30, and then we're looking at 4:30. The cars are 91 kilometers apart. If the cars had traveled continuously without taking any rest, find the speed of A. Suppose the speed of B was 12 kilometers or more. B was 12 kilometers per hour more. So if the speed of car A is x kilometers per hour, that of B is x plus 12 kilometers per hour. Also, since we're looking at a time of 4:30, A by then would have traveled for from 6 a.m. to 4:30, 6 to 12, 10.5 hours. And B would have traveled for 3.5 hours less, so 7 hours. In 7 hours, the maximum distance that B could have traveled extra could be 7 12s are 84, right? And therefore, by default, we can figure out that A would travel more distance than B. And therefore, we say distance traveled by A is 10.5x time into speed minus distance traveled by B is 7 into x plus 12. This difference should be equal to 91. Difference between the two cars is 91 kilometers. So 10.5x minus 7x minus 84 is equal to 91. 3.5x is equal to 91 plus 84. 175. X is equal to 175 by 3.5. I'm writing this as 35 multiplying by 10. 5 threes are 15. 15, 20, 75. And therefore x is 50 kilometers per hour. What is the speed of A? The answer that we get is 50 kilometers per hour. Even if you're not sure which car has traveled more, simply take the other difference, 7 into x plus 12 minus 10.5x is equal to 19. We'll get a negative answer, which will mean that this is a wrong equation. Overall, I think easy to moderate question should not take more than about 2 minutes to solve. And therefore, if I look at this test on an overall level, moderate sort of a test, difficulty wise, 6 questions, 18 to 21 solving time. Again, the questions that are to be solved will not take too much time, and the questions which probably are to be left are the ones which will increase the attempt time substantially. The question that I would choose in this test would be 1, 2, 3, 4, 7, and 10. Which are these questions? Basic question here, would have done this equation based, have done such questions earlier, therefore attempted this. This also basic trains question, no heavy concept involved, just the basic application of non-point objects. This also I would have done because I've done questions like this earlier. This was, I think, a challenging question unless you know how to do this upfront. Again, this question, the problem here was that a pattern had to be formed and then 12 minutes for the first time. And then you have to check for numbers, so could have been left. This, I think, was an easy question. Just put the variables and get the equations. I would have attempted this. This was a decent question. Till 30 cards, not a problem. Then there was an issue, could have left it. Again, this I think was a good question. May or may not have been attempted in the exam. This again was an easy question, would have done this always. So my selection would be 1, 2, 3, 4, 7, 10. Will give you 6 questions net net. The attempt time will also remain limited. And that is how your score can go up to 95%.